All right, let's get straight into it. Today, we are not just going to answer a GCSE physics question. Nope, we're going to tear it apart piece by piece to really figure out what a perfect answer looks like. And the secret weapon we're using? The official AQA mark scheme. I mean, have you ever sat there staring at a question, especially a big one, and thought, what do they actually want from me? What's the real difference between a decent answer and a full mark perfect answer? Well, that's what we're about to uncover. So, here's the plan. We'll decode the perfect answer by looking inside that mark scheme. Then we'll tackle the question itself, all about velocity, gravity, and acceleration. We'll get into that big 5-mark calculation, check out the final part of the question, and then wrap up with a solid blueprint you can use for any exam.
Right, let's kick things off. If you want to get top marks, you've got to learn to think like an examiner. And the best way to do that? Get inside their heads by using their own rulebook, the official AQA mark scheme.
And here it is. This is literally the key to everything. It's the exact guide examiners use to give out marks. It doesn't just tell you the right answer, it tells you the exact words, the specific steps you need to take to bag every single point. Okay, let's jump into the question itself, starting with part 8.1. This is a 3-marker, and it's all about those core ideas: velocity, gravity, and acceleration for a satellite. Let's see what it takes. So what does that perfect 3-mark answer actually look like, according to the people who do the marking? Well, this is it. It's short, it's sharp, and believe me, every single one of those words is there for a reason. Let's break down why. Okay, so check this out. Each of these bullet points is 1 mark. Point 1. You gotta say that gravity is the force causing the satellite to accelerate. Simple enough. Point 2, and this is crucial. That acceleration causes a change in direction. Not speed, direction. And finally, point 3 ties it all together. Because the direction is changing, the velocity is changing. See that? It's a perfect chain of logic, one step leading to the next. And that's why this definition of velocity is so important. A satellite in a stable orbit, yeah, its speed might be totally constant, but because it's constantly turning, its direction is always changing. And if the direction changes, the velocity changes. That little distinction, well, it's everything. Now, this is where it gets really interesting. This is the extra info examiners get. Look, they're told you allow it if you say the satellite is constantly accelerating. Great, but then look at this warning. If you say acceleration causes a change in speed, you lose the mark. Boom. That right there is a classic trap, and it shows you just how precise you have to be with your language. All right, time for the main event, the 5-mark calculation. This is where you absolutely have to show your work. But what's really cool is that the mark scheme shows us there isn't just one way to get the right answer. There are actually 2 perfectly valid methods. Okay, let's walk through method 1 together. First step, you pull the length of the orbit right off the graph. That's 42,100 kilometers. Easy mark. Next, you use that and the speed to figure out how long one orbit takes in seconds. Then, you see how many of those orbits you can fit into 24 hours. And for the final mark, you give the answer as the number of complete orbits. Every single one of those steps is a potential mark in the bag. And here's method 2, which is just as good. This proves there's often more than one way to solve a problem. In this one, you start by calculating the total distance the satellite flies in 24 hours. Then, you just divide that massive number by the length of a single orbit. And what do you know? You get the exact same number, 15.86. So, after all that work, all those calculations, converting hours to seconds, dealing with those huge numbers, what is the final answer that gets you the full 5 marks? It's simply 15. But hold on, why 15? The number was 15.86. Shouldn't we round up to 16? But this is where reading the question carefully pays off. This quote from the mark scheme tells us everything. An answer of 16 only gets you 4 marks. Why? Because the question asks for the number of complete orbits. It's a test of your reading skills as much as your math skills. Okay, we're almost there. Let's quickly knock out the last 2 parts of the question, 083 and 084. These are 1-markers all about looking at some data and figuring out what it means. So these last 2 are a really simple logical pair. For 08.3, you just have to make an observation. The predicted data is super close to the actual data. That's your first mark. Then for 08.4, you just state what that means. It means the data supported the prediction, which is good evidence that the equation they used is actually true. See? Just observation, then conclusion. Simple.
Phew, okay, so we've pulled that entire question apart. What have we learned? What's the blueprint for success that we can take away from this and use on, well, any question?
Okay, let's nail this down. Here is your blueprint for a perfect score. First, remember, velocity is not just speed, it has direction. That's a huge one. Second, show every single step of your calculation. Don't skip anything. Third, know that there can be different ways to get to the right answer, so be confident in your method if it's logical. Fourth, read the question like a hawk, paying attention to words like complete. And finally, use that extra information in the mark scheme to understand the common pitfalls and how to avoid them. And that's really what this is all about. It's not just about learning how to answer this one satellite question. It's about learning a method to approach every question. So I'll leave you with this. Go back and look at your own work, your own revision. Which of your answers could you improve right now by looking at it through the eyes of an examiner?